Peter had some beads. He used 1/5 of the beads and gave 1/3 of the remainder to Yenny. Peter had 8 beads left. How many beads did he have at first? So like I explained in the first concept, all right, when we see two fractions, do not just rush to make the denominators the same. Okay, because both denominators could potentially refer to two different groups of objects or two different groups of people. Okay, so let's analyze and break down first what each of the numerator and denominator represent first. Okay, so let's look at the first fraction. He used 1/5 of the bits. He used 1/5. Okay, so that means the 1 here refers to what he used. What about the 5? So of the bits, okay, the keywords are, I'll usually look at the keywords after something. So of the bits means of the total bits. So what it means is that the 5 here represents the total bits. Okay, moving on. Give 1/3 of the remainder to Yenny. So give 1 unit is to Yenny. What about the 3? Okay, so give 1/3 of the remainder, not of the bit, yeah? It's different from this one. This is of the remainder, so 3 units represents the remainder bits. And what does this remainder mean? So the remainder means that after he used the 1/5, then whatever is left, that's called the remainder. Okay, so as you can see, both the 5 and 3, they don't represent the same they don't represent the same quantity. They don't represent the same number of bits. Okay, because 5 is really the full total, 3 is only the leftover after he used. Alright, so we cannot make denominators the same for this. We have to draw a model. So typically when I see the word of the remainder, we call this a remainder theory question. Gotta draw a model from there. Okay, so I'll guide you how to draw. So let's start off with the 5 units total bits first. So this is your total. And out of this 5, we know he used 1 unit. Okay, now next thing is to identify the remainder first. Okay, so my remainder, of course, will be the remaining 4 units here. This is my remainder. Now, back to the second fraction here. He gave 1/3 of the remainder to Yenny. So just now we discussed that the 3 units here should represent the whole remainder. However, if I look at my remainder here, I do not see 3 units. 1, 2, 3, 4. In fact, I see 4 units. Okay, so how am I going to make sure that this 4 and this 3 both represent the same remainder? Alright, so not to worry. What you can do next is you just need to redraw the remainder in a new layer. Alright, so just redraw this remainder layer down. And from this new remainder layer, you can cut it into 3 parts. Okay, because I want my remainder to be 3 parts. So cut it into 3 equal portions. And there you go. Okay, so out of 3 equal portions, now we can label 1 portion is for Yenny. Alright, and if you read on, Peter had 8 bits left. So where's the left? Your left will be the last 2 portions here. Okay, so if you look throughout the whole stretch, alright, this remainder layer and the top unshaded part, they are exactly the same thing. Alright, so if you look at the whole stretch, your whole stretch is your total. Out of the total, you already used this. Yenny already took this. Whatever is left is really just this part. Okay, so 8 bits left is these 2 units here. And we can now go on to find the value of one of these units. Now, do bear in mind that the value of 1 unit here, the bottom layer and the top layer are 2 different quantities, for sure. Okay, as we can see, the unit sizes are already different, alright? So when I find 1 unit later, do not assume that the 1 unit applies the same to the top layer also. Alright, work our way from the bottom slowly to the top. Okay, we shall see how we do that. So 8 divided by 2 first. Alright, so 4 bits will be for each of these bottom layer units. Now, and I'm going to work my way towards the top layer. So your goal is to work your way towards the top layer now. Alright, so to do that, you can now find the whole remainder first. Find out how much bits is inside the whole remainder here. Okay, the blue one. So 1, 2, 3, 3 units. So 4 times 3. Okay, that'll be 12. So this whole remainder is 12. Now, I can now move my focus to the top now. Why? Because now I know remainder is 12. That means this whole unshaded remainder is also 12. Okay, the whole remainder is 12 now, which means that now I can find one of these top units already. 1, 2, 3, 4. This 4 parts represents 12. So 12, okay, so this is 12. You can annotate it now. 12 divided by 4. So 4 units means the top units, yeah? 1 unit will be 3. Okay, so the 3 is for the top layers unit. So how many bits did Peter have at first? So you want Peter at first? At first means the whole stretch. 1, 2, 3, 4, 5. Don't have to care about the bottom layer already. Okay, so the top 5 units is your total. So simply find 5 units and there you go, 15 bits.